Friends, in the solar energy, we have learnt the PV cells, production of silicon, and purification of solar grade silicon. In this video, we will learn the doping technique, that is, the addition of impurities in the solar grade silicon to make it high quality and more towards the semiconducting properties of silicon. Before we start this, please like my video, share and subscribe my channel also. The doping of silicon is the incorporation of little amounts of impurities in the substance to enhance its semiconducting qualities. And this property of adding the impurities is called doping. The added impurities are called dopes or dopants. So, to produce P-type silicon and N-type silicon, we introduce boron and phosphorus to the silicon respectively, as shown in the figure. Figure 1 is P-type and figure 2 is N-type. In the N-type, the phosphorus is incorporated, and in the P-type, it is the boron which is incorporated as the impurity. Don't forget this. Now, the techniques of adding the impurities in the silicon to enhance its semiconducting qualities. There are two techniques. One is the diffusion technique and the other one is the ion implantation technique. We will learn diffusion technique of doping of impurities in the silicon in detail. The principle is simple. In this technique, the dopant atoms, that is the impurity, is incorporated in the semiconductor material by simply diffusion and not by actually melting the metal. We will not melt the metal, but we will just introduce it with the process of diffusion into the silicon. So, the dopant atom moves into the empty spaces which are always present in the crystal lattice. By this technique, the extent of penetration of the impurity in the metal can be controlled to very little thickness of the material. With this process of diffusion, we can produce both N-type as well as P-type silicon. The extent of diffusion can be regulated by controlling the temperature and concentration of dopant atoms. The N-type silicon wafer is produced by heating the silicon wafer in an atmosphere of N-type impurities such as phosphorus just below its melting point. As a result of this, the phosphorus atoms condenses on the surface of the silicon wafer and slowly they diffuse into the crystal of the silicon, producing N-type silicon as shown in the figure here. The P-type silicon is also produced with the same process but in the atmosphere of P-type impurities, that is boron. So, if we just melt it just below the melting point of the impurity, it gets condensed on the surface and then slowly the boron atoms diffuses inside the silicon, forming a very thin layer of boron atoms in the wafer, producing P-type silicon. Now, what we conclude from this? The important things are that The future lies in the use of unconventional sources of energy like solar energy. It is the gateway to new opportunities in semiconductor industry. Much is needed to be done to improve solar cells and semiconducting materials because silicon is very expensive and therefore solar technology is also very expensive. So we can only suggest to produce cheap materials to develop and harness solar energy in the form of PV cells. Namaste.